Hello and welcome to the channel. In this episode, I'm discussing Planck's quantum theory. This is a very important theory because it dealt with the particle nature of the light. So let's meet on the other side to understand the particle characteristic of light. Welcome back. So we are discussing light has two characteristics. It can be a wave character and it can have a particle character. Now what is a wave? Now wave would be energy propagating in space. Now it is energy propagating in space. Now energy propagating in space means, say you are sitting in a room and facing north, and suppose you are singing a song, so it doesn't mean that the voice is only traveling towards north. Now the voice which is coming out of your mouth would be traveling in all available directions. So when the sound is traveling in all available directions, so it is termed as space. Space means 3 dimensions. So space is 3 dimension, and when we call any substance as a wave, then it should be the energy that is associated with that substance should be traveling in all the available directions. Then it is considered as a wave characteristic, and wave would have its peculiar things. It would have wavelength, then frequency, so wave would be associated with the frequency or wavelength. So these are the typical characteristics of a wave, that whenever we are saying light is traveling as a wave, that means it is spreading in all the available directions. So if you have say a tube light or a lamp in your room, and when you switch on, the light is traveling in all available directions, so that is a wave phenomena of the light. Now when we call it as a particle characteristic, so particle characteristic is a directional movement, energy associated with a direction at a given instance. So if you throw a ball in, say, north direction, so the ball would be now traveling towards north. It would not be traveling towards south, east and west simultaneously, isn't it? So that is the energy associated with that ball at a particular given instant would be the particle characteristic of the substance. So similarly, when we consider light as a particle character, so it is the Planck's quantum theory that explains the particle characters. So on your screen, you can jot down the difference between a wave and a particle character. So now let's see what is particle characteristic. So photoelectric effect is a particle characteristic. Say this is a photoelectric cell, and in this cell, say now light is made incident So now when light is made incident on this photoelectric cell, this is usually made up of cesium or the metal which has a very low ionization energy. So the electrons can eject out from the surface of the metal and they will start flowing in this direction. So this is a negative electrode and this would be a positive electrode. And if it is connected in a circuit, so we can convert this photons or light into electricity. So this is particle characteristic. So on your screen you can see the important points of photoelectric effect. You can jot it down or you can take a snapshot of the screen. So let's see Planck's quantum theory. Now according to this theory, the first point was that minimum energy is required to eject out electrons, and it is termed as threshold energy. And every metal has a specific threshold energy. So minimum energy is required. Say this is a metal surface, and if light is made incident on this, so electrons would be only ejected out if the energy is greater than threshold energy. The second point of this theory was frequency of incident radiation is directly proportional to the energy associated with it. So we can write E is directly proportional to frequency, and it can be just written as h nu, where h is Planck's constant and its value is 6.626 into 10 raised to power minus 34 joule seconds. So this was the Planck's constant. Now we know that frequency is related to wavelength by C. This is the relationship between frequency and wavelength. So replacing this frequency, we can have E is hc by lambda. So if we know the wavelength of incident radiation or the frequency of incident radiation, we can calculate the energy associated with the radiation. Now the third point was that number of electrons ejected out is proportional to intensity of radiation. So say you have a solar calculator, and if you're using that solar calculator in bright sun, then it would function as normal because the sunlight is falling on the solar panel on the calculator and it is producing electricity and it is functioning. Suppose that same solar calculator, you are in the room under a light source, which may be a tube light or a lamp. So it will again function normal. So we can say that white light is sufficient to eject out electrons, and then it will function normal. But say if you take that calculator on a day of Purnamashi day, that is full moon, that is on full moon, so what would happen? Would the calculator function? No, it will not function. So white light is falling on that calculator, but intensity of white light is very less. So the number of electrons are not ejecting out as required, and so it would not function. So intensity of radiation is very important. Kinetic energy of ejected out electron would be given by E minus E naught, and just reshuffling it, it would be like h nu minus h nu naught, where nu naught is threshold frequency. So we can have h is nu minus nu naught. So kinetic energy of ejected out electron according to Planck's quantum theory is given by E, kinetic energy is h into nu minus nu naught, or kinetic energy is given by half mv square. So now half mv square, kinetic energy is half mv square. So we can write half mv square is E minus E naught, or velocity of ejected out electron is 2 times E minus E naught over m under root. So by this method we can calculate the velocity of ejected out electron. So on your screen you have important postulates of Planck's quantum theory and the related formulas. You can jot it down or you can take a snapshot. So this is all about Planck's quantum theory. If you want to stay connected with us, then you can follow us on Facebook, Instagram and Twitter. If you haven't subscribed our channel yet, then do consider subscribing to the channel and don't forget to hit the bell icon to get instant notification. As a student, it's an urge to get yourself exposed to many questions so that you can build your confidence, and it's always advisable to attempt more questions and attempt more tests. So if you have such an urge, then you can follow the link which is on the top of your screen to satisfy your urge. Thanks for watching the video.